And we're live.
And we are live again. Hi and welcome, everyone. Thanks for joining our Terramate Office Hour, and it's already the fourth session in 2024. So, Søren, tell us, how is it going? How has the KubeCon been? Maybe you would like to say a few sentences about the conference last week? And maybe you can also tell us what's on the agenda for today's episode.
Yeah, for sure. Thanks for opening up, Selena. So, hey guys, thanks for tuning in. Very much appreciated. I'm Soren, founder CEO at Terramate. With me is Selena. She's guiding us through the process as always. Questions either in directly in LinkedIn or YouTube. I think we have some folks of our team there to answer them in line or just after the session as always. And yeah, about KubeCon. So I just came back from Paris. I'm in California right now, as you can see. Not wearing a Terramate shirt today. I actually forgot my stuff in Berlin. And yeah, KubeCon was great. It was really good to see, especially the movement around tofu during the first days. Was quite interesting. Hey Ayush, good to have you here too. And yeah, so we learned a lot there, met interesting companies, and really good to see what everybody is being up to. I think compared to the last KubeCons, it was a lot more open source centric, which was great to see. Again, Open Tofu Day was pretty packed. I mean, the room was full just after an hour of starting, and yeah, there was some interesting sessions conducted by Sebastian and the team, and I think they're already up on YouTube, so you can tune in there and check what's up. Yeah, and as of today, let me actually prepare and share my screen. Um, 1 second. Right. So here we go. Slideshow. Yes, so the focus of today's session, adding some spice to Terragrunt. And I think we talked about Terragrunt a little bit last time and how we think about Terramate in general. So we love Terragrunt. It's a great project, and but we see some challenges and that we also encountered whenever we used Terragrunt in our previous jobs. And yeah, today we want to focus a little bit on those. So how we can overcome some of those challenges with Terramate features such as change detection and orchestration, how we can integrate Terragrunt projects with Terramate Cloud to add some observability and deployment metrics and whatnot. But before we dive in, I'd like to just share some thoughts on how we think about Terramate. So the one thing that Terramate, I think, does really well is we basically add tacos, so Terraform automation and collaboration software capabilities to any existing Terraform, OpenTofu, and Terragrunt project and in any CI/CD, right? So we do support GitHub Actions, GitLab CI/CD, Bitbucket pipelines, Azure. You can run it in Kubernetes if you want to. Even Atlantis, an Atlantis integration is now available. And I think our mission here is to not touch the CI/CD space at all, but to basically provide values to teams that want to run on those platforms. So how do we do that? Terramate basically consists of two main components. So we have Terramate CLI that you already know. It's an open source project available in our GitHub organization, and Terramate CLI basically helps you to create, manage, orchestrate stacks either locally or on any CI/CD. We have quite some features here that we'll dive into in a minute. Yeah, and then there's Terramate Cloud. So Terramate Cloud basically provides better collaboration, observability, so you can understand what's going on in all your stacks, drift control, detection, reconciliation, as well as custom deployment workflows. And we'll touch a little bit on the roadmap in a second too. The one thing that I think we got right here with Terramate is that we do not try to replace Terragrunt or any of your existing tooling, but we seamlessly integrate with it, right? So while we have some overlaps with Terragrunt, for example, the code generation, You can certainly onboard Terramate in any existing Terragrunt project to provide value in literally less than 5 minutes. And it's done with a single command, which I will also show in today's demo. The way the Terramate basically works is, as said, we have the CLI. CLI runs locally on any CI/CD. And what we do different here to other platforms in that space is that we don't need access to any of your code. We don't need access to any of your state files, nor do we need to have access to any of your cloud accounts. Terramate CLI basically orchestrates commands such as Terraform apply or Tofu apply and uses those outputs of those commands in the produced plant files to send those in a transformed way to Terramate Cloud, where you then get the mentioned observability, etc. So it's pretty secure and it's pretty nice because you get to manage your state in whatever state backend you want to. You can use, of course, AWS S3, Google Cloud storage, even Terraform Cloud if you want to do that. So we don't limit you to that, and we keep your the data on your end, which is, I think, quite nice security-wise. So then let's dive a little bit into Terramate CLI. So what the CLI really does here is it has capabilities such as orchestration with change detection. And that's one thing that I think is really helpful in Terragrunt projects, because in Terragrunt, we either always run on one or all modules. So Terragrunt doesn't really have capabilities to detect whatever of your modules contain changes. And that's something that we'll showcase today too. We also have code generation to ensure dryness. So you can generate repetitive Terraform configurations, such as a provider Terraform, a backend configuration. But it also supports Kubernetes files, YAML, JSON, and whatnot. So quite nice. Streamlined workflow management. So you can basically invoke Terramate with pretty much the same commands locally on any CI/CD. Doesn't really matter. And you can also use Terramate to query whatever status your stacks have that are persisted in Terramate Cloud. So you can query for drifted stacks and then run Terraform apply just on those to reconcile drifted occurs. It also executes pretty fast. So because we have change detection and because we can detect on what modules have changed, what modules you would like to orchestrate Terraform commands, we can basically run change multiple modules in parallel, run those in parallel, and reduce the pipeline runtimes here significantly. As of today, the CLI integrates natively with Terraform, OpenTofu, and Terragrunt. We're adding support here for others such as Kubernetes too. And the language configuration in Terramate is built on top of HCL, the language that you already know and love. So we basically extend the language with a few Terramate-specific constructs here. And because of that, we'll basically provide you with a language server and IDE plugins for Vim and VS Code and whatnot. So now let's look a little bit at Terramate Cloud. So Terramate Cloud comes with a nice dashboard. It basically integrates with multiple GitHub, GitLab organizations and repositories, gives you a nice overview of what has happened inside of your repositories deployment-wise. Lets you understand changes introduced by teams and individuals. And those can be then assigned and managed by different individuals and teams as well. We do have support for deployments here. So the way that it's working is deployments run in your CI/CD and you push the data to Terramate Cloud to then understand like, oh, how did the plant files look like? Are there any failed deployments? Are there any drifted deployments and whatnot? We can create alerts automatically for those deployments too and route them in a clever way to Slack via Slack integration. And then you can also review and collaborate on plans and log files directly in Terramate Cloud. I already mentioned it comes with eDirect integration for merge and pull requests. So that's quite nice, helps you to review changes on a per stack basis. And we have like AI summaries in there. So basically to understand like, hey, what are the actual resources changed and provide this in a readable format so developers actually understand what's happening without needing to know how to read Terraform plans. It integrates with all your existing tooling, so Checkov, Terrascan, Trivy, and whatnot, right? So again, I think our philosophy is to integrate with whatever you have in a non-intrusive way and add those additional capabilities that make you more efficient as a team. We also leverage OPA, so Open Policy Agent, for governance, etc. So then there's drift management. Already mentioned that we have support for drift management in Terramate Cloud. Basically allows you to run scheduled drift detection workflows natively in any CI/CD. Yeah, you can configure alerts for detected drift and then decide whether you want to reconcile those automatically or not. In the future, what will be implemented here is also a way to import drifts directly to your code. So that's something that we're proactively exploring and working on, and we expect this to come to market later this year. The last thing here for the cloud would be routable alerts. So that's now coming too. Basically, we want to. So how this works traditionally is that most teams have sort of a centralized Slack channel where they just throw all those notifications in, like, hey, successful deployment, failed deployment, whatnot. So that doesn't really help so much because if you have 20, 30 or more notifications every day, it becomes quite spammy and it's not really actionable. So people tend to not look at this at all because, like, hey, too much. So what we do here is provide a Slack integration via Slack bot that directly pings individuals that own certain deployments or stacks based on code owners or even manual configuration that you can do in Terramate. And it integrates with incident.io, PagerDuty, Rootly, and whatnot. We also do have a pretty vibrant community on Discord. So if you're using our open source or if you want to explore the cloud, feel free to join our Discord at terramate.io/Discord. It's a great place to get in touch with individuals in our team that help you overcome challenges or questions in Terramate. And we're always happy to give you a review about what you're doing and whatnot. Roadmap, and then we'll jump into the actual demo of today. So what's coming now to Terramate is Dora metrics for stacks, deployments, etc. We're working on an AI blast radius detection to basically understand, like, hey, if you introduce changes to one stack, does that affect the integrity of another stack or not? LLM integration for scaffolding is coming now, so you'll be able to create new stacks via prompts. There's a service catalog for self-service deployments coming where you can basically configure certain Terraform abstractions and modules that allow you to deploy infrastructure following best practices in a self-service manner. We're working on a Kubernetes integration, as I already mentioned, and then there is context management and injection coming too. So let's assume that you don't want to have the actual configuration for your Terraform WAR files as part of your repository. Again, you can generate those if you want to with Terramate, but sometimes you would rather want to manage those in a centralized manner. So now we're adding a configuration store to Terramate Cloud, and you can use those on runtime, at runtime. So what are we exploring today? Basically, and I think we briefly touched this in the last session already. So I mentioned that Terramate can be onboarded to Terragrunt with a single command and without changing any existing configuration, which is pretty nice because it just means that, hey, for you to see value and for you to add features such as change detection, it really just takes a single command, right? And it does not require you to put hours and hours of engineering or migration work. That's not our intention here. We'll also add, as mentioned, orchestration change detection in Terragrunt's or Gruntworks reference architecture. So I came up with an example repository before this call that has everything done already. But I'll guide you through the process during this session for the next 30 minutes. We'll also look into how we can actually automate Terragrunt with Terramate using GitOps workflows in GitHub Actions. And by that, I mean plan previews, automated deployments, as well as scheduled drift runs and reconciliation. All right, so this were my 13 smart slides. Let's dive right in. So in our GitHub organizations here at github.com terramate.io, you can find this repository Terramate Terragrunt infrastructure live example. And it's really just a fork of what Gruntworks provides here, which is an reference architecture for Terragrunt, right? So they're explaining here how to use Terragrunt, using best practices, etc. But it doesn't come with any automation. And again, I think one of the main issues here or challenges of Terragrunt is this way of orchestrating what they call modules in Terragrunt. I think we refer to it as stacks in Terramate. So what we want to do today is to basically look at what we've done here in our fork and then show you how change management works, etc. So if we open my IDE here, VS Code installation, which is basically just the repository that I just showed a minute ago, checked out locally. You can see that a few things have happened here. So the reference architecture comes with this non-prod and prod environment. However, to not end up in endless runtimes, we'll focus on the production environment here today. And so this is exactly what comes with the Terragrunt reference architecture, with the difference that all of those stacks contain a file that is called stack.tm.hcl, which is basically configuration file in Terramate for you to declare a module as a stack. So what it does is you can create those with Terramate create all Terragrunt. So I've ran this before already. I'm not going to invoke this now. But what this basically does is it scans for Terragrunt modules, and then it will create those stack.tm.htl files in here that basically just contain a name, a description, and a unique ID. If we look here at our documentation at terramate.io/docs, let's look at this. You will be able to see that stacks basically allow for various configurations. So we can tag a stack with one or multiple stacks to then use text filter in whenever we invoke commands in Terramate. But we can also set an explicit order of execution with before and after, or configure forced executions with watch once and wanted by. And that's pretty helpful if we want to override the default order of execution in Terramate, which by default is following a similar sorting pattern than what you find in your local file tree. So alphabetically, and then it goes through all the different levels in your hierarchy. So a main stack first, and then nested stacks afterwards. If we jump back to my IDE here, so I've ran this already. For me to understand how many stacks are managed inside of this repository, I can invoke Terramate list, right? So now what you can see here is that basically Terramate detects all Terragrunt stacks or Terragrunt modules that have this configuration file with that command, right? And that's pretty cool, but what I actually want to see is I want to see how would those be executed if I orchestrate commands such as Terragrunt apply in here. So what I'm going to do is I'm going to use Terramate list, and I'll add a flag here, which is called run order. And this gives me an overview and an idea on, what stacks would be executed first and what's the hierarchy of the order of execution here. So what you can see is that I already mentioned it follows this it follows the same sorting than what we find in our local directory tree file system. So everything in non-prod is executed before things in prod. So I have deployed this infrastructure before our call, because otherwise an initial deployment for a database can take quite a bit of time. But what we want to do now is let's basically look at the MySQL stack here in the production environment, and let's look at how Terragrunt configures this. So what I'm going to do is basically I want to say, you know what? Instead of having storage of 100 gigabyte here, I want to increase this to maybe let's use 120 gigabytes, right? So what would the workflow be like with Terragrunt and Terramate, and how do we automate this in GitHub Actions? Basically, what I'm doing is I adjust this parameter here, right? So that's Terragrunt configuration. And the next thing I do is I basically check out a branch, and I call this scale the database storage. So now if I run git status, we can see that only this file changed, of course, right? So let me add this, let me check in this file and let me add a commit here. And I'm basically just gonna say, hey, feed, let's scale up our database to 120 gigabytes of storage. All right, cool. So that's pretty simple. That's the workflow that you already know if you use GitOps. But now for me to understand how Terramate actually works is, so Terramate can detect stacks that contain changes in your latest branch commit or pull request. And for me to do this, I can run Terramate list changed. So what this does now is it basically identifies that, hey, I'm on a different branch than our default branch. I'm on the scale DDB storage branch. And it understands that in this commit, during this commit that I just created, we basically only changed something in this MySQL stack. So now if I want to invoke a command in here, I can say, hey, Terramate run, changed, and then let's say we just echo hello world. So what this does is basically it jumps into the stack, right? And it runs the command echo hello world. If we were to change two stacks, it would do this sequentially in both stacks. Of course, I can also say something like, hey, parallel 5. So this would be this would run 5 stacks in parallel using threads and Go, but it's somewhat irrelevant to today's demo. So what does it mean for my actual workflows? I'm gonna do the following. I'm gonna push this to the repository origin, and then I call this scale the DB storage. So, and then I'll just open this up in GitHub, which is in here. So let me create a pull request and let me just make sure that I don't open up this pull request to the origin, to the grunt work repository, but a Terramate repository. And then I use the main branch here because I configured the branch to be main. So now what I'm going to do is I'm basically just add a title here. No description, doesn't matter for the demo. And let me open a draft pull request. So in the meantime, to explain you what happens now. With Terramate, we basically created some workflows here, GitHub Actions workflows, and we created a workflow for deploy, for preview, and for drift detection. So what we can see now is Terramate runs in GitHub Actions here. Could be any CI/CD, really could be GitLab, Bitbucket pipelines, or whatnot. And it basically says like, oh, okay, it's a Terragrunt project. And there were some changes introduced in the commit with this specific hash. So now it runs and it will give us as an output what has happened here. So if you look at this workflow, see how this looks like. It installs Terramate and Terraform and Terragrunt and whatnot. It changed the code integrity here. Then it lists the change stacks, right? It authenticates to AWS. And hopefully this is working now. This already takes a long time for whatever reason. Here we go. And now it initialized Terragrunt only in change stacks. So what you can see is we say, hey, Terramate run in the production folder. Just no parallelism here, on change stacks, and then run Terragrunt in it with a certain timeout. And then next up, it will orchestrate the Terragrunt plan command. So if we look at this command, and that's interesting, what we can see is basically say, hey, run Terramate, use Terramate to run Terragrunt plan and output the plan to auto TF plan. And now we set a few options here. So we say, hey, this can be done in parallel, no problem, on change stacks only. And we want to sync this preview that we generate here to Terramate Cloud. So we go back to our pull request. What you can see now is that basically Terramate gives us a nice overview here directly in GitHub Actions that has us understand like, oh, so what has changed here? Only one stack, USES1 prod MySQL. And then it shows you the actual change. So, oh, there's a resource AWS DB instance, which is somewhere in the Terragrunt modules here. And basically change the storage from 100 to 120 gig. If we would look at Terramate Cloud, so this is the Terramate Cloud interface. This is just a demo organization of ours. You can see I can use multiple organizations here. It's quite nice. And there's a pull request integration. So now this pull request integration basically tells me, oh, you know what? It syncs the data from GitHub Actions to Terramate Cloud, and it provides me with an overview of what stacks have changed and then how the preview looks like here. But not can you, you can, not is it only about the Terraform previews, you can really send the output of any command here. So you can send the results of InfraCost, of Checkov, of whatever tooling you already use, and basically enrich this interface and then run computational actions on you. Cool. Let's move this to ready for review. And assuming that somebody would have reviewed this pull request here, what I can do next is I can basically merge this. Don't do this at home. Usually you want to have those changes reviewed. So now if we look at our GitHub Actions workflow here, what we can see is that, all right, so it triggers another pipeline. And what it does is basically, this is the deploy workflow that we configured here. Again, it's part of the repository. You can just fork it if you want to. And we're about to, I think, release a blog post on how this works and what we discuss here in a day or two, really with detailed instructions on how to set this up too. So let's look at how this works. Basically, we run Terragrunt here again. This time Terragrunt apply on whatever stacks contain changes. So you can see, oh, it detects again that now the branch was merged back to main, but still it uses then the main branch, the last two commits or the newly introduced commits from our branch that we just merged to the previous commit that we created a branch from to basically come up with a diff. So that's based on Git, pretty nice. And then it understands like, hey, so this specific pull request, this specific branch that we merged back to main only contained the change for one stack, and now run Terragrunt apply here. So what we do here is basically we say, hey, use Terramate to orchestrate Terragrunt apply. And you can see this runs already, so it modifies the database here in AWS. And of course, we set flags here again in Terramate that we say, okay, only run this on change stacks, and then sync this data to the cloud. So now if we look here at the cloud, you can see it's a deployment running, right? And the nice thing here is it shows us basically deployments from all repositories that are connected to Terramate Cloud. So for example, you can see here is a different, this is a different repository. So let's look at this. This is a repository called Terramate Quickstart AWS, which is another demo of ours. But then the deployment here is basically running in Terramate Terragrunt infrastructure live example. And it shows you an overview of all your stacks. So we only touched one stack here now. Let's look at this workflow. It still modifies. It just finished now. So this workflow should finish any second. And also too, what's interesting here is that the one way that many people get drift detection wrong, I think, is that they run it only periodically after an deployment. Whereas the way that we think about it is like, hey, once you deploy a resource, you should run a drift detection on this specific stack, on all resources deployed inside of a stack right away. Because resources can change, right? So you may deploy a load balancer that scales up and down on autoscale, it scales up and down right after deployment, and that would cause a drift, right? Just yeah, could be one use case for this. So what we do here is we run a drift detection right after we apply changes to understand, hey, are there actually any drifts occurring inside of our stacks? So now if I go back to Terramate Cloud here and I look at this, we can see the deployment is successful. And the health checks would show an alert now if we would have detected a drift, but that's not the case, right? It didn't drift right away. And again, I can see like, oh, okay, so this is the apply Terraform plan here. I can see specifically the logs lines that are interesting for me. So it syncs all this data back, right? So that's kind of the workflow. Now, if I go in here and I say, okay, let's check out the latest changes, that's pretty nice. So now I have the code up to date from whatever I just merged. So now what I can do here is I can say, hey, you know what, Terramate Cloud login, and I can use the CLI, and I'm just going to do this real quick to log in to the cloud. So this worked. I just opened up another browser window on my second screen. So for me to get an overview of all my list now, I can say, hey, Terramate list. Yeah. And then I can say Terramate list cloud status failed. Yeah. So this would give me an overview of all my failed deployments. Let's say there's some stacks that for whatever reason the deployment has failed. So now I can query those directly with Terramate CLI to understand locally or in any CI/CD if some of my stacks are broken, right? And I can, of course, also say, hey, drifted. I don't think we have any drifted stacks here. We actually do have. So there is a drift. That's interesting. We can look into this in a minute. But what is important here to understand is that basically we can say Terramate run and then add this drifted status to Terramate run. So now it would only select stacks that have drifted. And we can say, hey, maybe we also want to add a tag whenever a stack has drift and it has the tag auto drift reconciliation. We just run Terraform apply. So, in doing so, to give you an idea here, basically allows us to automatically reconcile drift in all stacks that are declared as failed or drifted, or redeploy stacks that have failed previously for whatever reason, with either invoking this locally on any CI/CD with many workflow triggers and whatnot. So let's go back to the cloud. Let's look at our stack list here. What we see here is, oh, and this has drifted right away. That's interesting. So in fact, there was a drift detected, and I don't know why, but it seems like it scaled the storage down automatically. Probably because of not enough usage, because the database is basically empty. So we could address this now, but I actually don't want to reconcile this drift. I just wanted to show you how this looks like. So now it has an alert. The stack has an alert. It's like, hey, this update has drifted for whatever reason. So now if we look at the stacks list here, I can see and query for failed stacks. How's these stacks? I can look into like, hey, just show me everything in this Terramate Quick Start AWS repository. And then I can basically say, okay, so now I would just like to see what's going on here. So this is a failed stack, and it wasn't deployed probably, and it basically has a drift too. So this stack, I believe, there was a mistake in the actual deployment, and the deployment aborted, and that causes a drift, right? So now it shows me the plan that it produced in order to resolve this drift. So this gives me a nice kind of like overview of all my stacks managed in multiple repositories and multiple organizations. What else is there to say? So in Terramate, we don't work with API keys. Okay, we abandoned the concept of API keys for security reasons. Instead, Terramate is just working with OIDC, and that's either locally or in CI/CD. So what you can do in Terramate Cloud is you can actually configure your GitHub organization, your GitLab organization, then it creates OIDC workflow identity providers in the backend, which means you will be able to communicate from Terramate CLI to Terramate Cloud without any additional authentication needed. Of course, you can also, on and offboard members to and from your organization here. We have Slack notifications that I already mentioned that can be configured here too. And yeah, it basically allows you to give this kind of overview and better understanding on how your ISC actually looks like by onboarding your team and then assign ownership and what not. So I hope I could give you a little bit of an idea on how we think about it. I think the main difference is that, traditionally you would basically run Terragrunt apply all, right? And that's bad, because again, Terramate apply all runs sort of on all stacks and it's expensive and it also creates bigger blast radius, etc. So now overcoming this with Terramate can be done by adding orchestration and change detection. And also too, as mentioned, I think the one critical thing here is that, hey, if you were to onboard Terramate to your existing Terragrunt project, you can actually do that, but you don't need to change any configuration, right? So you can see value right away, really by just running a single command that onboards the stacks configuration here, but it will never touch any of your Terragrunt configuration, and it does not require you to, oh, I need to migrate from A to B, which is always a pain in the ass. So we don't necessarily look at this in a sense of we're trying to replace Terragrunt here. There's some overlap, stuff that we haven't shown here is the code generation in Terramate. I think we had this in one of our previous office hours. Check out the recording if you're interested in that. But the code generation Terramate can be used to natively generate native Terraform such as provider and backend configuration. So the main difference here to Terragrunt is that, yeah, it generates this code as native Terraform code, which makes it suitable to be used with any third-party tooling. So you can integrate this with really any tooling in any platform, as you are not moved out of native Terraform. Awesome. So that's it. That was a quick rundown. Quicker than expected, but I hope that makes sense. And all right, let's look at the questions here. All right, so first question is, does the change detection for Terragrunt actually support to detect deeply rooted changes? So that's an interesting question. And if we look here, let me just quickly show you the documentation for that. So if we look at our documentation at Terramate CLI onboarding Terragrunt, so the way that this basically works is already said, okay, onboarding Terragrunt adds all those features, right? Change detection, execute any command, run any CI/CD and whatnot. But if you look here at the orchestration and then the change detection documentation, what we do with Terragrunt is basically we process and detect changes in any referred configuration inside of your Terragrunt modules. So why is this important? Let's assume that you're including a local or remote module in any of your Terragrunt configuration. So now, if that contains changes, right? If the model contains changes, as the stack actually does not, right? Because the stack usually only has the configuration, how to configure this module, but the actual module is not part of your stack. So what Terramate does is it detects changes in module references in Terragrunt dependencies, which are basically Terraform output. So you can keep using those and it will trigger all dependent stacks, right? If any of those contain changes. That's pretty nice. And it can detect this like, hey, did this Terraform module or those Terraform modules that I use here contain changes? And that's pretty neat because it's a common problem in a lot of the platforms out there that, yeah, basically they will not be able, so even in some of the tacos providers, you will not be able to detect if a stack has changed when a reference model has changed. So that's something that we overcome here, right? So the way that we think about change detection is basically has different integrations, and the integrations in Terramate can be extended. So this basic integration for Git, this is what we showed today for Terraform, for Terragrunt, OpenTofu, but then also specific local files if you want to watch, I don't know, a secrets file or whatnot, right? Doesn't really matter. So it supports all of those use cases. And then depending on what integrations we'll add here, perhaps Kubernetes also will elaborate on those too. All right, so let me stop sharing my screen. Next question is parallelism supported for Terragrunt 2? Yes, so Terragrunt already supports parallelism for running Terragrunt commands, but Terramate also does that. So the main difference here is that if you run Terragrunt, you basically, and I mentioned this early in the call, apply either one stack or all stacks, right? Or one module or all modules. So now in Terramate, if you use Terramate because you want to use the change detection, you usually invoke commands on one stack at a time. So if you have five change stacks, Terramate would run those sequentially. However, with the parallel flag that we just showed a couple of minutes ago, you can basically set concurrency and limit this to a certain number of threads. And the nice thing is the main difference to Terragrunt is I think Terragrunt by default always uses unlimited concurrency, which means that just use all available threads. If I'm not mistaken, might be wrong here, but if I'm not mistaken, it will use all available threads and run many API calls in parallel. So now the problem with that is that basically you can run into quotas, API limits of the different providers that you manage, right? AWS, Google Cloud, whatnot, and hit errors. So the way that we think about it in Terramate is like, hey, per default, we always limit parallelism to a thread to concurrency of one. But if you want to set this explicitly, you need to provide us the amount of concurrent operations that you would like to see here. So good default for this is 5. Everything else, I think, quota API limit wise, you could hit shit could hit the fan here. But feel free to try this out yourself. Right. Selena, do you see any more questions?
Actually not.
And it's expensive and so creates. Great. Okay. That was just, I think, my stream. Cool. Well, then I would say let's sum up. Thank you guys so much for joining today's office hour. Hope we could give you a good understanding on how you integrate Terramate with Terragrunt, how you can integrate it with Terraform Cloud, the value add that you see here. And yeah, we look forward to have you in 2 weeks from now on.
Weeks.
Yeah, I think there's a set webinar scheduled soon, or we need to schedule this first. But yeah, what were you meant to say, Selena? Sorry.
Just the next office hour is already scheduled for the 10th of April, I think.
Awesome.
So thanks for joining, everyone.
Yeah, right after the Easter vacation. Okay.
Yes.
Yeah, thanks for being patient with me too, Selena. I should give you more word in sessions. But yeah, let's leave it to that, guys. Wishing all of you great Easter holidays, wherever you are in the world. I'm closing here from California. Thanks for dialing in and have a good day. Bye bye.
Bye bye.